Alright, so this is continuing the lecture on fatty acid synthesis. The last video we talked about how melanocoa was created, which because it is used as a building block for elongation of our acyl group or our fatty acid chain. Alright, so we're going to fast forward into about to begin that elongation process. Alright, so the enzyme that we're going to be talking about is a fatty acid synthase. Okay. Attached to that fatty acid synthase is going to be a malonyl group, which we already created, and an acetyl-CoA, alright, attached at different spots. Okay, so there are going to be four major reactions to the elongation process of fatty acid chains, and that's going to be a condensation, reduction, dehydration, and then a subsequent reduction reaction. Okay, think about, like I said in the previous video, this is the opposite of beta oxidation. So let's begin with that condensation reaction. We're going to have a nucleophilic attack of the acetyl-CoA to that carboxy group, or replacing that carboxy group of the malonyl-CoA. So we're going to kick out that carboxy group. It's going to leave as CO2, and we are going to elongate our chain by 2. So we're actually losing 1 and gaining 2 for a net gain of 1. Alright, and that's going to be the whole process. Every single time that we elongate, we're going to kick off a CO2. Alright, so that was condensation. Next, we're going to reduce. Alright, because remember that acetyl group that was just attached, alright, that's going to have a double bond O. We don't want that in our finished product. So we're going to reduce it by using NADPH. Notice how I'm saying pH, alright? The only time that we talked about that previously, or that you have heard of, was in the pentose phosphate pathway. But we'll talk about that later. Alright? Just know that that's what we're going to be using for our reducing agents. Okay? NADPH. So we're going to use NADPH to reduce that double bond O to a OH group, a hydroxy group. Okay? So that's condensation, then reduction. What's next? That's right, dehydration. And dehydration, you're going to be kicking out that OH group in the form of H2O. So that H2O is actually going to come from one of the neighboring carbons, that alpha carbon. Okay, so what's actually going to be happening along the way of kicking out that H2O, we're actually creating a double bond between the alpha carbon and the beta carbon. Okay, and after that point, that's dehydration. But once again, fatty acids, saturated fatty acids, don't have double bonds within them. Okay, so we need to reduce it once again. So we're going to reduce it using which one? NADPH. We're going to use NADPH, reduce it, getting rid of that double bond carbon between beta and alpha. Alright, now how does this go on? Alright, well, that this new chain, this new acyl group is actually going to transfer itself over to the starting position of where acetyl-CoA was. At that point, another malonyl-CoA molecule is going to attach itself to fatty acid synthase, and this cycle is going to repeat, alright, until we get the fatty acid of the desired length. Okay, so let's talk about reagents, and let's talk about products. Okay, so reagents. How we use an ATP to create a malonyl group. Alright, so for every addition step, we have the use of one ATP. Alright, and as well, for each elongation, we need an acetyl-CoA. Alright, and last but not least, for the ingredients, we have NADPH. Alright, I'm not going to include the hydrogen ions, just know that they're there. Okay. Alright, right, so that was the ingredients. Let's talk about the products. Obviously, we're going to have the acyl group, but another product, remember that we kicked off that CO2, and then we also have the H2O. Alright, so CO2, H2O, they're leaving. Another products that we can say that are present is ADP, one for each, and NADPs. All right, 2 for each elongation. So 1 ATP per elongation and 2 NADPH or 2 NADPs per elongation.